Hello team, this is Wes Weimer here with a video guide for writing a Lexer for cool, this time using OCaml and its built-in lexical analyzer generator, ocamllex. We will cover reading in the file specified as an argument, the ocamllex documentation, token definitions, line numbers, lexemes, even a live submission demo. Let's really hope that works. And then maybe some error handling at the end. It's going to be a lot of fun. All right, one of the first things we will do is pull up the submission webpage, and ideally we will have read all of the rules for programming assignment 2, the specification in advance. One of the first things that's worth paying attention to is that you necessarily have to name your file main.ml and include a MLL file. More on that in a bit. And as a personal challenge, we're going to try to do this video guide in one take. Following, say, Alfred Hitchcock's Rope, a movie shot where it increases tension by appearing as a single continuous take. We're going to see how that goes. All right, so here we are. We have a blank directory, and we're going to get started using ocamllex. All right. Lexer and parser generators, overview of ocamllex. We'd read up a bit on this, and it turns out that we're going to write a special MLL file, and a tool is going to automatically turn that into OCaml source code for us. All right, so let's keep reading to see what format it takes. Yeah, this is a formal definition, but I do not have time for that noise. I bet if I keep scrolling, there will be some sort of demo, possibly even a calculator demo. All right, we saw one of these here. Rule tokens. All right, let's actually keep looking. We've got that documentation, but ocamllex documentation. I can't spell documentation, but Google's going to help me out anyway. All right, overview of ocamllex. Now, this seems to be pretty much the same thing that we saw before. Start, rules, error handling. Aha! But a complete example. This is just what I wanted. The all-time favorite. A desk calculator. We've hinted in class that all languages are required by some mysterious law to do this desk calculator example. You'll see it pretty much anywhere you go. This is the parser file. That's PA2 for us. We don't want to do that. But this Lexer, this seems pretty cool. All right, and we will just pull in some of this code right now. All right, and one of the things we see is that there's this region up at the top inside these curly braces, and you can put any OCaml code you want here. So, Wesley Weimer, WRW6Y, Lexer for PA2. We don't have any sort of parser, but this end of file exception seems pretty good. One of the things I'm also going to do here, since I've read the programming assignment to requirements, one of the things we have to do is keep track of line numbers. First line of a file is line 1. All right. Because the line number changes over time, I'm going to break with functional programming tradition and make a mutable variable. It's going to start at line 1. That'll be our line number, and we'll track it and increment it as time goes by. We're also going to keep track of a number of different tokens. They've got, integers, plus, minus, times, divide. For the purposes of a simple demo, let's not do any of these. Let's just do integers and plus. And we'll want to make our own abstract data type to keep track of what our tokens might be. All right, so the tokens for us could either be integer or plus. And we could add a few more later, but that's going to work out quite well for now. And then we see this part here that says rule token. And you can have multiple rules, but this is the main one. Rules like a keyword in ocamllex. And token is a name. We could have another rule that was for comments. More on that later. This says parse, but they really mean lexing. This is a really bad naming for them. And then you just give a bunch of different regular expressions. For example, maybe one of our regular expressions is spaces or tabs are some sort of white space. And our way in ocamllex of ignoring something is to call ourselves recursively again. We're in the middle of rule token, trying to find an answer, but if we see white space, we just call rule token again. LexBuff is, again, for lexing. This is just part of the tool that you have to learn to do these sorts of exercises. This stands for lexing buffer. It's essentially the input. It's an implicit argument to any of our tokenization rules. All right, so we're going to skip over blanks. All right, what we're doing here, we are skipping whitespace. All right. We'll also have a rule for new lines, and we'll want to skip that whitespace, but before we do that, I will want to increment our line number mutable variable, and then keep reading. All right. And now, we'll make a little comment here. Much of this code is adapted from it's amazing that I can spell English. From the calculator example in OCamllex. All right. So now let's unpack what they've got going on for integers. This main part here, 0 through 9 plus, this is the regular expression they're using for integers. This as lexeme part, all right, stores whatever string we actually got here as this variable lexeme. Notice this code in curly braces. Whenever one of these rules is matched, we execute the corresponding code on the right. So here we can return an integer token. And let's actually have the integer token. We're going to keep track of the particular integer that we saw here. So we'll just add that like this, integer of int. All right? And then similarly, if we see this plus, we will just return plus token. And to make this look a little prettier, I will move all of these over because why not? We're computer scientists. All right, so we're returning these tokens. Now, as it currently stands, we're not actually doing anything with line numbers. More on that later. But now there's sort of a final part we can have in one of these files. Down here, we can have another one of these curly brace maneuvers, and we can put any sort of OCaml code. And one of the things I recommend, all of my OCaml programs start with this magic incantation, because then I never have to worry about semicolons again. So somehow I'm going to need to call this Lexer or invoke it on some input. And let's just go see how they actually do that. All right, so we're going to steal this code too. Get into paste mode. And then we'll walk through and see what's going on. So one of the first things they do in this code is it makes this LexBuff variable, that's the same one we're mentioning up here, this lexing buffer, from a channel, and the particular channel is standard in. That's fine for now, but remember that later we're going to want to read from a particular file. So we'll just do this for testing. And then they've got another one of these while true loops that are somehow so popular whenever we're doing imperative OCaml code. And they say, okay, our result is parser. Oh, no, none of this parser stuff for us. All right. They want to call Lexer's token rule. Because I'm conveniently doing this all in one file, we don't need to say Lexer dot. We want to get a token from the LexBuff. All right. And they print out the result. I will just print out, I saw a token. Opened up my eyes and I am happy now. All right. And then eventually there will be some sort of end of file and we will exit. All right, so we've been writing for quite a bit, and now it's time to think about doing a little bit of testing. Let us make some sort of cool data file, and we'll put like 1 plus 2 in it. So hopefully we'd see 3 tokens in that and not 5, because we're going to skip over the white space. But this isn't an ML program yet. It's one of these MLL files. So we run ocamllex on main.ml, and if everything worked correctly, this is just debugging output. This stuff about states and transitions, that's about the finite state machine implementation of lexing, which we will totally cover in class. But it should have produced for us magically a main.ml file. Let's just take a look inside it. We don't actually have to understand it, but we'll look just for fun. Notice that it has all of the code from inside these curly braces here at the top, but then in the middle it's got some data values, and it says these are tables. This is a transition table implementation of a finite state machine. This most of the transitions are 0, but some of them go to different states. Blah, 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 transitions coming out the wazoo. Here are all of our rules, like return plus. And then way at the bottom, you can see our main. Okay. So if all of this worked, we should be able to compile with OCaml opt this file. Now this would assume that there are no errors in our OCaml program the first time, no type errors, and that never happens in Lake Wobegon. Let's see what happens. Unbound module Lexer on line 31. Ah, yeah. So we just want, we don't have a Lexer file name, we're just doing it all in main, so this exception EOF is just right here. All right, now you'd think we could just rerun it because we fixed that error, but actually we're going to get the same message because main.ml didn't change. We need to regenerate it every time, and then if that works, we can try to compile it. All right, so it tells us that we're not using the variable result, which is totally true. We'll get back to that later. But now I should be able to run main and say something like 1 plus 2, and oh, we saw 3 tokens. Okay, we're doing quite well. All right, so now we want to start printing out what these tokens actually are, and we're going to use one of these match statements. There are only 2 options for the token. We put them right up here. If it's a plus, then we print out plus, and if it's an integer I, we will actually print out that value after the word integer. Let's compile this again, remembering that every single time you have to rerun ocamllex. A lot of people will make a makefile for that. I recommend it. All right. Let's make very different integers so that we can see if it's actually working. Ah, and here we see the integer 1, and then a plus sign, and then the integer 5555. Ah, this is looking pretty good. But, pardon me, but remember that for PA2, we also need to print out line numbers. And we've hypothetically been tracking them, but we're never actually returning them. So instead of just returning the token, let's actually return a pair, the current line number, and then this token we care about. Current line number, and then this token we care about. Current line number, and then the token we care about. And we will always print out the current line number, and then the token we care about. Let's see if this compiles. Ah, it totally compiles. 1 plus 2. And we see that integer 1 was on line 1, plus was on line 1, but this other integer was on line 4. 1, 2, 3, 4, 5, everybody. All right. So this is looking really great, but we are not supposed to read from standard in. Instead, we are supposed to read from a file. Oh man, I cannot remember how to read in from files in OCaml. Save me, Google. File manipulation, OCaml. How do I read in lines from a text file in OCaml? All right, something like that. Ah, we've got this this open in file. That seems pretty good. So let us have our file handle is open in. Oh, we need to know the file name. All right. Well, the file name is supposed to be passed as a command line argument. So now I need to know how to access command line arguments in OCaml. Well, it looks like we've got this sysargv. This is actually pretty much the same as it is in Python, but OCaml uses a slightly different syntax. To access elements in an array, you use normal parentheses instead of like this. Like, that would be wrong. This is correct for OCaml. And we probably want argument number 1. So then once we have that file handle, instead of reading from standard in, we can read from that file handle. All right. Let us see if this compiles. Now, it seems to compile. Do I have any cool files lying around? I've got this data cool file. All right. Let's see if I can run main on data.cl. Oh, that totally, man, that totally works. On line 1, we've got the integer 1. On line 1, we've got the plus. And on line 1, we've got the integer 2. Let's just move some of this stuff down. So now we want line 1, line 2, and line 4, and we'll make these integers, different so that we can see them. And let's see if this still works. On line 1, we had 1, 1, 1. On line 2, we had plus, and on line 4, we had 2, 2, 2. Well, that looks actually very good, except that we're not supposed to write to standard out. We're supposed to write to a very similar file, and we are only supposed to write there if nothing goes wrong. Actually, what does it look like when something goes wrong? We haven't tried any error conditions. Let's say I take my data CL and I put in something that we would never want to match. Maybe something we would totally want to match. I don't know. We like Irish music quite a bit. We are a sucker for fiddles. But we don't have any rules for this I. So let's see what's going to happen here. We've got some sort of failure. It's going to raise some sort of exception. All right. So presumably down here, in addition to end of file as an exception, right, we could also have any other problem. Now we're supposed to report errors in a very particular way. Error reporting, we're supposed to write this. All right. So line number, and then we'll leave the message for later. And the current line number is line number. Remember, because it's a mutable variable, if we're reading from it, we have to pass in this bang every time. And then whenever there is an error, we should exit. And because I never trust OCaml to do this binding correctly, I'm just going to put a little begin end there. All right. Let's see if we can compile this. And now let's see if we can run it. Great. We've got a Lexer error on line 3. And indeed, line 3 is where the problem is. But you'll notice that we're printing out the output and then the error. And the problem specification says we must either do one or the other. So as we saw with Rosetta, a typical solution to this is to store our output in some sort of buffer or string. Now, we could just put it in a string, but if you're in the OCaml video, you're probably already interested in some cool ways to do things. And it turns out the recommended way to do this is to use OCaml's buffer. All right? And you can add in things to buffers or print into them. And you may have heard that if you keep appending to the end of a string, that can have order n squared behavior, and the buffer uses a slightly better data structure. So we will make our magic output buffer. All right. Where did I learn about this create method? I totally saw it on this webpage. And then, instead of this normal printf, we're going to have bprintf, the buffer print maneuver, and print this to our out buffer. And print this to our out buffer. All right, every time. Oh, and this one up here, print this to our out buffer. All right. And now, if we reach the end of file naturally and there are no errors, all right, we can do a bunch of things with this buffer, but maybe one of them, just for now, just for testing. All right. We can print out the contents of the output buffer. So in this world, we are only going to see, we should only see, the correct successful output if there are no errors. Well, let's try it. Can we even compile this? Outbuff. Did you mean output? No, I really didn't. I liked output quite a bit. But they're actually correct. I'm trying to access this buffer, and I declared it inside the try, but then I wanted to see it in the finally block. What am I thinking? Let's declare it out here. Oh yeah, much better. All right. So now, when I rerun, we only get the Lexer error message, but let's say I copy data to something like goodcl. We remove that, and now I run main on goodcl, and great. All right, except that we're still writing it to standard out, and we were supposed to write it to a file. Right, so here, our file name is sysargv, and we'd like to say plus, but in OCaml, to concatenate strings, you use the caret. Why not? Right. And now we want to make another one of these file handles, and I'm just going to guess, without even inspecting the documentation, that we'll use open-out instead of open-in. All right. And now instead of just printing, I can print to a file with fprintf. Right. These things like printf, fprintf, they should remind you of C. Indeed, most of OCaml's standard library functions are named like the C versions. And then I will want to close this file handle. And because it's an output file handle, I'll use close out. Let's say I'd forgotten that, though. Could I have found that out anywhere? OCaml, how to write to a file. And here we see this same open out and close out and fprintf stuff. So we could have gotten the same thing from Stack Overflow. I was just pretending I remembered it. All right, let's see if we can compile this one. Oh, my favorite type of error message. This sort of thing with a format, this almost always means that you've gotten something wrong near a printf. And they're exactly right. On line 40, we forgot a semicolon. Yes, that whole error message for you forgot a semicolon. Complicated error message because it thought we were passing extra arguments to printf. It thought we were doing that. And it's like, oh, well, close out doesn't match with printf, blah, blah, blah. All right, so now it works perfectly. So we've got data.cl and good.cl. When we run main on good.cl, we should see nothing. But now there's this clx file that looks like it has some of the right answers. All right, big bucks and no whammies. All right, we could actually try to submit this. Oh, that trick never works. Let's see how things go. Well, remember, we are required to submit not just our main ML file, but also this sort of MLL source file so that the instructor or the TAs can grade it. So we will just zip up all of those, and then we will head over here to the submission website. We will log in, and now we will pause for just a moment to make sure I can find the file in the right place. I could totally find the file. We're submitting the Lexer, and we're just testing. All right, big bucks and no whammies. Let's see how it goes. Well, this looks great. We are passing this positive test case, integers 1, 2, 3 on one line, integers 1, 2, 3 on multiple lines, and even instant pluses. And that's good because that's what we said we would do. Oh, and look down here. Illegal character on line 1, we're totally doing correctly, and illegal character after an int on line 2. We're doing everything correctly. And this is actually pretty much it. You would then go on, to just add in some others. In addition to plus, I want minus. It looks something like this. And then down here, something like that. And we would recompile. And you would want to do that for, can't find it harder. And you would want to do that for every one of the tokens, paying special attention to ones like string and comment, which are a little trickier. You may want to use Lexer states or a very complicated regular expression. But that is the basic plan. Good luck with programming assignment 2.